Hi, my name is Ben Miller and I'm a hospital pharmacist, and today we're going to do allegations. I like allegations because we use them in real life. We had a couple years ago, we had a shortage on dextrose 20% bags. So we had a doctor who wrote an order for dextrose 20%. Sometimes you'll see it as D20, dextrose 20%. We didn't have it in stock, but we did have dextrose 70%. And we had dextrose 5%. So the dextrose 5% you'll see is a D5, dextrose 70% could be D70. So we had to mix the 5% with the 70% to give us the 20%. So let's work on the problem. So the first thing you do is you're going to put the higher concentration on top, which in this case is the 70%. So we have 70% on top. And then the 5% we're going to put on the bottom. And what we want to make, we're going to put in the middle, which is 20% over here. Okay. So now what we're going to do is 70 minus 20 is 50. 20 minus 5 is 15. And what we're going to do is we're going to add these two numbers to give us the denominator. So that's going to be 65. So just to give you a quick recap, we want to make 20%. We only have 5% and 70% in stock. So we're going to mix the two to give us the 20%, and we want 1 liter, 1,000 ml. So what I did was I subtracted 70 minus 20 to give us the 50, 20 minus 5 to give us the 15. Those are the numerators. To get the denominators, I added these two numbers, so 15 plus 50 gives me 65. Now I'm going to multiply it by 1,000 because that's what the doctor wants. He wants a liter. He wants 1,000 milliliters of the 20%. Okay, we're also going to round it off to the nearest tenth. Depending on the exam you're taking, they'll tell you to round it off to the nearest tenth or the nearest hundredth, so just pay attention to that. So we are going to do 15 divided by 65 times 1,000 is 230.76, and we're going to round it off to the nearest tenth. So we're going to have 230.8. So we're going to have 230.8 milliliters, and then we're going to do 50 divided by 65 times 1,000, 769.2. All right, so for the 70%, we're going to take 230.8 milliliters of the 70% solution, and we're going to take 769.2 milliliters of the 5% solution. And you want it to equal to 1,000 milliliters. So if you take 230.8 plus 769.2, that's going to give you 1,000 milliliters. Now sometimes the professor may give you a problem where he's asking you for 500 milliliters or 400 milliliters or whatever the quantity of the drug that he wants. So all you have to do is just change this. So instead of multiplying here, you multiply it by 1,000, so multiply it by 500 or multiply it by 400. So it depends on the quantity that the doctor orders. And that's our first example of this alligation problem. We use it in real life. I've used it in real life. It's pretty easy once you get the hang of it. And we'll just do a couple more just to give you some practice. Okay, let's go on to the next one. Okay, we're back. We'll do problem number 2. So we have a doctor. He writes an order for 1.5% sodium chloride. So we have 3% available in the hospital. It comes available commercially. The only problem is you can only give it through a central line. Now the patients don't always have a central line, So sometimes the sodium level of the patient is so low and you want to supplement it really quick. So we prepare a preparation of 1.5% sodium chloride. So this is something we have to compound in that V room. So the doctor wants 1.5 sodium chloride and he wants a liter, 1,000 ml. Now in real life, you'll see a lot of the orders are for a liter or 500 ml, 250 ml, 100 ml. We like to keep things, first of all, the bags we commercially buy in the hospital are 50, 100, 250, 500 a liter. There are some cases, depending on medication, where we'll use empty bags and we'll use, depending on how much is needed based on the drug and the minimum concentration. So you'll see different amounts. But normally we like to keep stuff in those volumes of what comes commercially available. Okay, so back to the problem. So we want 1.5% sodium chloride. 1.5%. The pharmacy, we stock at 3%. We buy it from the company. 3% sodium chloride. It's hypertonic. And we have sterile water for injection, which will dilute with the 3% to give us the 1.5%. So the question is, how much do we have to use? So again, we're going to do alligation. So the higher number goes on top. So we have the 3% is what we're going to put on top. 3%. So here there's a little bit, it's not a trick, it's just something you have to know. Sterile water gets 0%. So the lower number goes on the bottom, and the 1.5% goes in the middle, because that's what you want to make. So whatever you want to make always goes in the middle. So 3 minus 1.5 is 1.5, and then 1.5, 0, 1.5. So for the numerator, I subtracted 3 minus 1.5 to 1.5, and 1.5 minus 0 to give me 1.5. And then to give me the denominator, you just add these two numbers. So you got 3, and okay, so we're going to multiply it by 1,000. So just to give you a quick recap, we want to make 1.5% solution, a liter, 1,000 ml. Commercially available, we have a 3% bag, and we also have a bag of sterile water for injection. We're going to mix the two to give us the 1.5%. The question is, how much of each do we need to mix? So we put the higher number over here, 3%, the lower number over here, sterile water gets 0%. So 3 minus 1.5 gives me 1.5, 1.5 minus 0, 1.5. So we get this denominator here by adding these two numerators here. So 1.5 plus 1.5 is 3. So now we're just going to do the calculation. We're going to do 1.5 divided by 3 times 1,000 gives you 500 ml. And same thing, 1.5 divided by 3 gives you 500 ml. And again, these two numbers have to give you the total of the volume that you're looking for, which is 1,000 milliliters. So 500 plus 500 is 1,000 milliliters. Okay, in real life, I don't have to do this calculation because I just grab a 500 milliliter bag of 3%, which comes commercially. I grab a liter bag of sterile water for injection. We have a pump in the hospital. I pump out 500 milliliters of sterile water. I pump 500 milliliters of 3% into an empty bag. Both of them go into an empty bag. It gives me a total of 1,000. So I just wanted to go through the calculations just so you can see. But when you actually have the stuff in front of you, it's obvious that you just dilute with an equal volume. So I just want to give you a caveat to this question, because sometimes you don't have the 3% bag available. We do have vials of sodium chloride that come 23.4%. So let's do this calculate. This same problem, but instead of using the 3% bag, we're going to use the 23.4% vial. So let's just, I'm just going to rewrite this using 23.4%, and we'll go through the calculation. All right, so we're going to do another alligation problem. In this problem, we have a pharmacy technician has a 3% ointment and an 8% ointment. And we want to make a 5% ointment. So when you ever have two different strengths and they want you to make a
another strength, that's an alligation. That's we're going to use the alligation. So here we have 3%, we have 8%, we want to make 5%. So we're going to put the larger percent, the 8% on top, and then the 3% goes on the bottom. What you want to make always goes in the middle, 5%. So we do 8 minus 5 is 3, 5 minus 3 is 2. To get the denominator, we just add these two numbers together. So that's 2 over 5, 3 over 5, and we want to make 100 grams. So we're going to just multiply this by 100. Okay, just for a quick recap. So we have 3% ointment, 8% ointment, we want to make a 5% ointment, and we want to make 100 grams. So what we did was we put, again, 8% is the higher percentage on top, 3% the lower percentage on the bottom, 5% is what we want to make. So 8 minus 5 is 3, 5 minus 3 is 2. So I add the two numerators, 2 plus 3, to give us the denominator of 5. And we multiply it by 100 because 100 grams is what we want to make. So we're going to do 2 divided by 5 is equal to times 100 is equal to 40. And then 3 divided by 5 times 100 is equal to 60. So we have 40 grams and 60 grams. So this 8%, you're going to take 40 grams of this 8%, and 3%, you're going to take 60 grams of the 3%. So 40 grams of the 8%, 60 grams of the 3%, and that's going to give you a total of 100 grams. That's going to give you a total of 100 grams with a concentration of 5%. And that's how you do this alligation problem.